Hello, everyone. Welcome to Track C and your session on commercial data washing machines. Now, this is the most interesting title of the entire conference. It's no surprise because your moderator is none other than Richard Wang. So, Rich, I'm going to let you describe this session and introduce all your panelists, and I'm looking forward to a very interesting conversation.
Okay. Hi, everybody. I'm Rich Wang. I'm the most disorganized person, but I have 4 very good friends coming together for this session. Dr. John Talbot from UA Little Rock has been with Exim and with me for more than 20 years. And Solomon from PyLog, he has a perspective about what a commercial data washing machine is. In fact, he claimed that he announced the first data washing machine in the 1990s. And then we have Victor Bocking from Deloitte. He is the domain expert in Deloitte's approach for data washing machine. You'll be amazed how he defines it. And then finally, I got Andy Palmer. I always want him to talk with me on the Themis data washing machine. Finally, we got him. And so in the beginning, you hear from Dr. Talbot about entity resolution and how they do it. And at the end, you hear Andy talk about how he should upstage the entity resolution approach. Each person should get no more than 5 minutes of time. And after that, we open up like a Lincoln Douglas 5 people style. You ask questions, Wayne Eckerson will announce a question, and anyone can jump on it and review. So with that note, let me start mine. So next slide, please. Okay, so here you see, okay, that's me. Next slide. Okay, so back in 1990s, I started the idea of data quality. I asked simple questions, which is when it comes to information quality or data quality, what came to your mind? And that was a seminal paper that I published in JMIS in 1996 called Beyond Data Accuracy. In other words, data quality really go beyond accuracy to include many other dimensions. Now is well established. And so for the last 10 years, I've been looking at data warehouse, the ETL, data cleansing, data profiling. And I said, well, if we want to provide pure data, couldn't we be doing like cleaning code to develop the concept data washing machines? So let me make a disclaimer. I don't know what I'm talking about here. This is strictly a brainstorming session today, but the industry thought leaders have their approaches. So let's listen to them. Next slide, please. So that's 25 years ago. And now we're coming into the stage. So when I ask people, what is data washing machine? They, of course, the first answer is, well, a machine that cleans data. Well, that's so fulfilling. So here I at the end of this PowerPoint, as well as I put in a working paper that you can download, we begin to frame the problem. And at the end, there was a few responses that we get from UA Little Rock's National Science Foundation researchers. And one simply said, a data washing machine is a methodology or a process providing clean quality data. Never thought about that. Another response is, get a Maytag. They make data washing machines that never break. That's another interesting thought. And then data cleaning to remove unwanted records. So you can see there are different approaches, and this is pretty much like when in 1995, when I published that Beyond Accuracy paper, that opens up the landscape of many research papers in practice. I'm hoping that today's session will generate similar kinds of breakthrough, opens up our idea as to what constitutes a data washing machine or data washing factory or whatever you have. Next slide, please. So there are different views of CDO in terms of implement data washing machine. You can have an engineering view looking into how you can build the best engine for data washing. Or you can say, okay, I have data washing different kinds. Some is called a spatial data washing machine. like Einstein's special relativity and others are general data washing machines. You punch it to, push button, a few buttons and produce the data fit for your needs. And the others say, well, I got the data all cleaned up. It's like a gasoline station. I can give it to you. I provide it with a service and finally to a service chain model. All kinds of things that you can have. Next slide, please. So I'm not going into details, but to show you that we actually come up with a scheme to say, well, gee, this may be a process for us to think about data washing machine and see how we go forward on this one. Next slide, please. Okay, so as I said, we have done some preliminary work. At the end of this PowerPoint and in my working paper, you can find some of the responses. And we have a plan studies, different approaches depending on who I can recruit to work with me voluntarily to produce all these research results. And at the MIT CDIQ program, we will also do this as well. Next slide. I think that's the end of my slide. So with that note, I'll introduce the next speakers on the current academic research and industry practices. Next, John, would you like to introduce yourself a little bit?
Well, sure. I'm, as the slide says, Axiom Chair of Information Quality here at the University of Arkansas at Little Rock. I have some industry experience through working in the R&D organization at Axiom Corporation, and I try to remain active in consulting with industry, especially around data governance, which has inspired a lot of my feelings toward increasing the level of automation. So next slide. So, this is a common thing we hear all the time, that data scientists complain they spend 80% of their time preparing and only 20% of their time using it. And so, that to me is a call to arms. So that, these smart data scientists, we need to kind of eat our own dog food and redirect a lot of what we're using, machine learning, graph technology, and these other cool things, and redirect it back to the beginning of the process in getting data prepared in an unsupervised way. So really working on a larger goal that the data washing machine is a part of, and that is trying to automate the entire data curation process from acquisition through data quality analysis, cleaning, data integration, standardization, and usage, and all the way through disposal. So, and right now that's largely a human mediated process. We have a lot of cool tools that help us, but it still basically requires a lot of data analysts to accomplish. Next slide. So Rich and I are both working along with several other faculty here at the University of Arkansas Little Rock on a National Science Foundation grant that is called DART, Data Analytics That Are Robust and Trusted. And it has 5 major thrusts, but the one that Rich and I are working on is this particular one that I just mentioned, automation of data curation. And we've got 3 tasks that we're working on right now. The first one is integrating multiple sources of the same information, which Rich pointed out in his book several years ago, The Journey to Data Quality, is the #1 data quality or root cause of data quality issues. Also working on positive data control and staging and automated processes of genomic data. That's being led at the University of Arkansas for Medical Sciences. And some of you may have heard on our panel this morning, there's active work being done on positive data control. But I really want to focus in on this first one. Next slide. And that's the main use case that we're working on right now, is this multiple sources of the same information, which I mentioned is very common. All of the credit reporting agencies have this big time. This was a huge problem at Axiom when I was working there. And it's funny how things change. We had the tribute yesterday to Larry English, and one of the things I remember about Larry is that he said, wow, the greatest enemy of data quality is data redundancy. But when we're looking at how to do this in an unsupervised way, it actually turns out to be a good thing. If I've got many copies of the same information, I can compare them and try to sort out which ones that I believe are the best one. And that gives me a way to cleanse the data. So the way we're approaching the problem from our research perspective is to invert the current paradigm. So currently, we analyze each source and try to standardize it to a common layout and then put that into our match engines or our ER processes, which are expecting that everything is uniformly standardized, that it knows where to find the first names in all of them and the addresses and the street numbers and so forth. The way we're trying to approach that in an unsupervised way is to do the entity resolution or the matching first in an unsupervised way without having to depend on the metadata. And then once we get the references or the records into the same cluster, then we can use this approach that I was talking about of comparing them and see how that we could clean them and then potentially standardize them. So we're trying to turn around the current paradigm. And of course, Dr. DeJager will be talking here shortly, is also one of our industry partners in this grant and sits on our industry advisory board and helps us by providing some real world use cases to work on. Next slide. So again, here's our current approach is the traditionally you take each source and run ETL, and typically you have to have analysts to understand how to do that ETL. And once everything has been brought to a common format, they're merged, and then the merge file goes into the ER process to produce the clusters that of the same information, same patient, same student in order to integrate. And the approach we're taking, as I pointed out, we just merge the sources first, even though they have different layouts, because we're basically right now discarding most of that metadata, the annotation, and run that through an unsupervised ER process, which does token comparisons, build the clusters, and apply the unsupervised cleaning to those clusters. And we know we're not doing a very good job the first time, but as we get better, we can iterate this process and finally get to a good set of high quality clusters. So this is my 5 minutes of explaining our approach. As I said, even though our goal is all of data curation, we're focusing on this most common use case of integrating, multiple sources that may have different layouts. And we're taking an ER or a matching first, and then using that to leverage the cleaning and doing this in an iterative kind of way. So I believe that's the last slide that I have. Next slide. Well, no, I got one more slide. And that, I did want to mention just briefly that another part of what we're working on is automating data governance operations, in particular, keeping the data catalog up to date. And again, here I wanted to point out, we've got a couple of industry partners that are helping. Dr. Justin Magruder with SAIC is also sitting on our industry advisory board, and Cash Mehdi, who's with Informatica, is also on our advisory board. And they're both very much involved in helping to automate data governance. But today we're mainly focused on automation of the curation, in particular the data quality and data cleansing. Next slide. And so that takes us to Solomon.
Solomon?
Yes, good day, good day. Next slide, please. Maybe keep it there, just there, yeah. Just on one thing, the topic that I want to talk about is about ontologies and the role of ontologies in this. And to understand that, you need to understand a little bit where we're coming from in the last more than 30 years. So I was part of a group that from scratch started to develop what is today still the South African Defence Logistics System for the Air Force, Army, Navy. And that rolled over and is also run in the Royal Air Force in the logistics system. But since 1995, as Pilock, we started to specialize, especially with our ex-NATO experience over many years. And that was to specialize in the commercialization of the NATO templates into ISO 8000 open technical dictionaries, which we used for cleaning and structuring of multilingual characteristic data for e-commerce and governance and master data and ERPs. So this experience that I want to share with you, as Rich said, in our washing machine, comes from application in many industries. Next slide. So over the last 30 years, we applied this to large mining groups, plants, aeronautical defense, petrochemical, energy, oil and gas, iron and steel, nuclear, airports, aviation, construction, etc., etc. So this is where our experience comes from. Next slide. And in short, this is a slide. It took me some time when Rich asked me to dig up and went through my old Commerce One e-commerce slides of 1999, when we created some of the first content and enhanced created machines. Very primitive, but it worked at that point in time for us. So it is a matter where you have lots of supplier data, which we had to throw in a type of washing machine, like you say, and we had to figure out what's the part numbers, what sort of codification is in there, what's the classes, value extraction, data resolution, and that went into sort of a washing machine iterative cycle to feed into structural data under governance into the ERPs of today, like the SAPs and others, and actually building a buyer catalog. Next slide. So what it actually did, and a little bit more in detail, if you can see, typically on the left-hand side, we'll get unstructured descriptions coming from all sorts of sources by the millions. And that would be typically a buying description. So this washing machine would take a description like we have on the left, and then try and figure out what of this data matches actually the stock item, and what of this matches various part numbers within that stock number for the company. So we had to run stuff and figure out who's the supplier. Is this a part number or not? What is the class in there in terms of the object? Is a bearing ball, or what's the type of item? What's the attributes describing? This is where the NATO templates come in terms of inner diameter, outer, or whatever the template describes, the values of that, the unit of measures, and whether it conforms to a codification system. So we allocated types to that, completeness weights, multiplied, and came out with sort of matching stuff. And that was early days. Next slide. So if you don't believe me, that is a copy of the 99 washing machine desktop. We called it Spukavuk, which was supplier, part number, object, qualifier, attribute, value, unit of measure, constructing or template washing machine. That was in 99. Okay, so much for the history. Next slide. What I want to share with you is where we are today, and John referred to it because we do, over the last years, a lot of R&D work with Arkansas Little Rock and with Reach and so on. And in my opinion, why we struggle with artificial intelligence and machine learning, and why that's a challenge in cleaning and structuring data for products and services, especially if it's of a very high engineering content, like you see our users bases are. Because products and services are driven by taxonomies, ontologies, hierarchies that has classes, subclasses, characteristics, associated values, references, unit of measures, quantity of unit measures, etc., etc., etc. So machine learning models or algorithms needs various comprehensive data sets with higher volumes, covering all possible formats, patterns, with lots of variety in order to achieve the greater accuracy of levels. And just a matter of interest, if you look at the NATO templates, there's 55,000, and you have to figure out, And each of them has got multiple levels of characteristics, unit of measures, etc. So what we find with the AL with the machine learning models, why we struggle to achieve better and consistent accuracy levels, and that's because of the lack of consistent metadata that creates unparalleled discrepancies with regards to terminology, lack of classified legacy data for training purposes, lack of a variety of domain expertise. That's a big issue, depending whether we work with ball bearings or enter into the medical field, for example, and of data sets covering all these possibilities. Dimensional values resulting from conflicting information, like length, breadth, height, width in a diameter. You get a value and you don't know to what does it conform of those areas. Lack of predefined unit of qualifier of measures within the data sets. Lack of established terminology for equivalences. One guy will call it inside diameter, the other guy will call it bore, and it's the same thing. Inconsistent implementation of data standards. That's why we do a lot of work in the ISO 8000 and data standards area, and various specifications defining the same form, fit, in function. Lack of large volumes of data sets to cover all the commodities and services. And of course, the last is over-ambiguous objects and goals and expectations from our customers. So this is all from my part in the 5 minutes. I hope we can discuss in the Q&A a little bit further, but thank you very much for this opportunity.
Victor?
Hi. Yep, I'm ready. So, yeah, hi, Victor Balking, and you know, I'm kind of lead what we're calling our advanced data management practice at Deloitte, and you know what we're trying to do there is leverage cognitive and AI techniques to improve data management, and that's what I'll be talking a little bit today. You know, for the last 5 years, I've been, you know, applying AI techniques such as machine learning and natural language processing to help clients, you know, to build what we're calling here data washing machines. And I like the word, but a lot of my clients are in the banking industry. So talking about like washing and laundering and things like that, you know, I may not use this term with them. But, you know, what we're trying to do is help them to accelerate and automate, you know, what Richard mentioned and my fellow panelists mentioned are, you know, typically very highly manual, costly, time-consuming data management, data quality, and data stewardship type activities. Innovations I've seen over the last few years have been happening across all industries, but specifically I see a lot happening in life sciences and financial services since they are highly regulated and tend to also have a high cost of compliance. Next slide. So AI capabilities that can be leveraged for a data washing machine. Typically, you know, what we've been doing is using a combination of these techniques in the various implementations we have done for clients. So, you know, a main one, and we're lucky that the type of use cases we're trying to solve in, say, financial services or, you know, these other industries are not as challenging as what Solomon mentioned from an engineering perspective, because, you know, definitely I agree with some of the challenges he's presented in terms of using ML and AI for doing some of the activities there. So, you know, machine learning, you know, and we use a couple of techniques. One is you know, supervised learning. That's where you kind of provide the inputs and the desired outputs to train the model. And we'd use unsupervised learning techniques where, you know, the models try to figure out the patterns in the data themselves. Another component we use is natural language processing, and mainly, you know, through trying to understand text description and extracting meaning from the data. And that was very similar to the example that Solomon showed in terms of looking at the engineering descriptions and trying to extract attributes and assign it to the appropriate fields through that process. Intelligent automation or robotic process automation, RPA, and that's to help automate some of the manual processes. And then the other one is intelligent text and image extraction, which could be used to help enrich data, or predict missing values. And I have a couple of examples of that on the next slide. And then to a certain extent, using natural language generation, which can be used to help generate commentary on data quality reports and things like that. So it's more consumable by the data stewards or other executives. So what we've done is we've combined these capabilities into a solution that we've called the Cogni Steward. And we've implemented this now at over 50 clients across multiple different industries. So let's go to the next slide, please. So for data washing machines, there are basically four broad categories of use cases we've implemented, through which we've been able to achieve 25% to 80% savings in the effort of improving the quality of data. So these categories are data validation, correction, and enrichment, anomaly detection and control monitoring, data deduplication and merge processing, and then grouping, hierarchy, and taxonomy generation. Most of our implementations have been in the first category and also in the data deduplication category. Common problem that similar to what John mentioned in his talk. And so some of the examples here are fairly self-explanatory, but if I wanted to look at the first one in the first column, once you've defined the various data quality rules for the types of data that you have in your data sets, the next hugely time-consuming activity then is assigning all those rules to the appropriate fields. So what we've done is we've developed machine learning algorithms that will help do the automatically assign those rules to the various fields in the data set, saving a bunch of time there. Another one I'd like to point out is for anomaly detection, we're basically applying a similar technique for both use cases. In a sense, we're kind of auto-generating data quality rules and processing by having the algorithms trained using historical data, and then learns how the data kind of correlates to itself. And then can identify and take action when some issue is detected in the data that's anomalous to the typical historical patterns in the data. And we use various techniques like short, long, neural processing, as well as there's like automated regression, integrated moving average type techniques, and various things like that. I have data scientists on my team that work on these various problems for our clients. And I guess the last one, as I'm running out of time here, is that it's really around the data deduplication problem that John was talking about. The approach we've taken is that a lot of the vendor tools out there have various matching engines that either use deterministic matching or probabilistic matching, but that only gets you so far. So what usually happens is it can make decisions as to, yep, definitely these two are different persons, or definitely these two are the same person based on the matching engine. But there's usually a gray area where, hey, the algorithm's really not sure, so let me send this off to a data steward to make the final decision. So what we've done is we've implemented a machine learning algorithm there that will learn from what the data steward is doing to process those duplicate records. So then it could automatically process similar records and therefore greatly reduce the effort of the data steward in those situations. So the good news is that most of the vendors, and we're going to hear from one in a minute, have been able to start implementing these capabilities inside their products, so that it's a lot becoming easier and easier for clients to implement this for themselves in their organizations without having to do some custom development. So that's my 5 minutes. So let's go to the next slide, and I'll hand it over to Andy.
Andy.
Excellent. Thanks, Victor. Really excited to be here, and it's so much fun to have this conversation because we've all been thinking about the same problems for a really long time. The heart of our work started 11 years ago at the Computer Science and AI Lab at MIT, where my partners, Mike Stonebreaker and Ehab Elias and I, along with 3 postdocs, began working on the problem of doing very, very large scale data curation for tabular data. And the paper that we published is, I just published in the link in the chat session. And now after 3 years of research and publishing the paper, we founded the company Tamer to commercialize the academic work. And we've been through now 3 major commercial versions of the system that are now available to use natively on the large cloud platforms, AWS, GCP, Microsoft Azure, as well as Snowflake and Databricks. And at the heart of our system are a lot of the same ideas that Victor and Dr. Dieger described. And I'll just take you through a few of those right now. But we've really been trying to do this sort of in practice at the largest companies in the world for cleaning up a lot of their internal structured data. Next. So the first and foremost, the enterprises has got a sort of large enterprises have a huge crisis of trusted data. There's way too much data and it's way too dirty. So like the demand for the washing machine has never been higher. And this is especially true as all these large companies try to do their digital transformations. Many of them are realizing that in order to do any cool AI stuff or even just empower their line folks in their business with data, that they've got a huge effort to clean their data. So the appreciation for clean data in large enterprises is never been higher. And building, trust around data is really kind of what this is about at its core. And ideally, building a feedback loop. As Victor and Solomon were describing, is a very, very powerful missing piece of the equation in the enterprise. Most data in the enterprise flows from sources down through to where it's consumed, and there's no bidirectional feedback mechanism. I describe this missing piece oftentimes as JIRA for data. We need a, sort of the equivalent of JIRA for data and data quality, where consumers can provide direct feedback, and it can get queued up and then prosecuted by stewards and curators. Next. So it's really remarkable, the scale of the data variety problem and the data quality problem in the enterprise is massive. And when we were doing our research, we really focused on bringing data together, unifying and mastering and curating data from many hundreds of thousands, even millions of tables. But it's remarkable if you go inside of any one organization, what you find are people that each have a very small view of the big data quality elephant in the enterprise. And so many people sort of are incapable of appreciating the scale until you zoom out to the broadest level. And early on at Tamer, we had a really simple question from one of our biggest customers, which was Jeff Immelt when he was at GE. He said, "Are we getting the best terms every time we buy something at GE?" And the only way to answer that question definitively was by integrating supplier and purchasing data from many hundreds, about 275 different ERP systems that represented about 1,500 tables, and the resolution of those tables and the data in those tables was only possible using the kinds of machine learning techniques that we've been talking about today and that we have implemented in Tamer. And the resulting benefit of that activity of unifying that data and then running the simple analytic, low-hanging analytic was over the course of 3 years, more than $500 million a year. So $500 million a year of savings realized just by cleaning up the data. And so it makes the investment required, you know, to do the data cleaning look like very, very, very small peanuts. Next. And, you know, like sometimes we, you know, there are these conversations about in the enterprise about, you know, you get religion about, you know, rationalization. We just need to get down to one system or one warehouse or standardization or aggregation, or even now people are trying to sort of do a lot of federation. You know, our argument is that all of these things are sort of, you know, useful, but none alone or even all of them together are sufficient in order to solve this, the washing machine problem. That it's much bigger. You need to try and do a lot of these things, but you have to, you know, sort of take a much more holistic approach. And again, only when you use sort of these, you know, next gen machine learning techniques that are tuned specifically for the washing machine and for cleaning up data do you get, you know, the kind of the best results in our experience. Next. So getting to this trusted data, you know, as we dug in and experimented for 3 years with all the math that you might use to do large scale schema mapping. Are these two attributes the same or different? Record matching, are these two records and the entities in them the same or different? And classification, if I call something X in one table, is it the same as Y in a different table? And doing that in a probabilistic way, we really came to the conclusion that supervised learning was kind of the right approach to take, and an approach that really emphasized sort of machine-driven but human-guided approach, where you have this very iterative expertise, as you know, Victor was talking about a little bit, where you know you get SMEs involved very directly, was the right approach. Next. And so, and really what you have, you know, the entity resolution problem, as we've been talking about a bit, you know, it's sort of a classic n squared problem. And, you know, we spent a lot of time and, you know, a patent around how to do, you know, break that, hack that n squared problem for entity resolution using adaptive binning. It's kind of one of the key components that we think is sort of a best in class approach. Next. And then, but matching is really only part of that picture. You know, clustering is a much more difficult problem, and you know, we've significantly reduced the complexity, you know, of that problem, and you know, used really efficient intra-cluster parallelism, and you know, we think this is a really effective way to solve sort of the clustering problem. Next. And then you've got this classification problem that doesn't scale, which, you know, is very, very challenging and very compute intense. And, you know, we've sort of, you know, using, you know, adaptive blocking and hierarchy pruning, we've eliminated a lot of the redundant work required and sort of hacked this classification problem pretty effectively. And kind of as Victor and Solomon were describing, like, there's a combination of these different algorithms and these, you know, in context of a broad sort of data washing machine pipeline that is the right way to sort of approach this problem at scale. Next. And so, you know, really, you know, delivering, you know, trusted data is what this is all about. And the core problem is the variety of this data, which oftentimes is inside of one domain, inside of a company, sort of broken down into some number of 100 or so sort of key logical entities worth of data. And for us, we really view the problem as this sort of like n squared, you know, 2 n squared problems plus maybe an n cubed problem thrown in there. And that using the tremendous availability of cloud compute resources, along with some of these highly specialized algorithms, has been very effective for us in cleaning up a bunch of data for, you know, very large, for large enterprises, and really focusing on automation and the automation of these pipelines and the dynamic generation of data so that you can adapt the pipelines very aggressively as the data changes. Next. So that's mine, and hopefully that helps a little bit. But again, we've been doing this. We've implemented the washing machine for call it 60 or 70 large companies with lots of different variations and all kinds of challenges. One last comment maybe is that the biggest challenge for us, is rarely technical. Oftentimes the human and behavioral challenges with regards to data inside of our customers tends to be the biggest, even though we're using some really cool advanced machine learning and we're really proud of our math. At the end of the day, how people behave with regards to data is often the biggest challenge, and engaging subject matter experts is so critical in the process of solving these problems, not just because you need their feedback to tune and tweak the models over time, but also because you need their buy-in to the importance and them feeling ownership of the data. Thank you very much.
Thank you. We're back to Wayne. We have about 17 minutes for free-flowing questions and answers. Wayne, do you have any questions from the audience?
Yes, we do. We do have a few. One with a lot of votes was there's a lot of mention of data curation and data catalogs. The question was, what do you see are the biggest challenges in automating the data catalog, which was mentioned at the outset?
Any taker?
I'll take a start on that, Rich.
Okay.
Just on the data catalogs, because that's been our bread and butter for 30 years. And I think structuring things in a data catalog is one thing, and cleaning data with a washing machine is also one thing. But the thing that's the most neglected, is the governance of that data afterwards, because we found if you don't put any governance structures in, very quickly, it becomes dirty again, specifically with the catalogs. So that's where the application of templates, like typically these adjusted NATO templates. And what the template will do, it will put a framework of the characteristics, but that framework is used for the governance model itself. So if you say this is a commodity, like a valve or bearing, a characteristic would be material. And then the material would actually say, okay, but what's the material? So if the material is stainless steel, it opens up another template, because is it a 306 stainless steel, a 117, and from whose standard? Because that depends on what's the makeup of that. And is it now Ruski standard from the Russians or Germans or wherever? So the catalog area is a tricky one. So unless you start putting your templates right, and just to give you a practical idea, I mean, NATO, for describing almost everything, has got 55,000 templates. We found that in a big petrochemical plant, we could describe 1 million items in a catalog using something like 3,000 templates. And that's scalable. And now you need to get all the variances of unit of measures, et cetera, et cetera. So the challenge is actually, to get that into that. And not to throw another thing in, but John, maybe to link it a little bit of the R&D work we did at Arkansas, was if you get these catalogs and they are actually handwritten, from 30 years ago, how do you get that handwritten forms or text specs in a digital format and then into a template and then into a catalog? And if you start putting that in a washing machine, exactly the same form, handwritten by one guy, the machine learning will not recognize it to the next guy. So to me, the secret is to get these frameworks and then start putting rules around it and more get more data. That's just I hope that helps.
Anyone else?
What I'm seeing, there's two basic approaches that people are using on automation of the catalog. One is to say, people have got all these systems out there. I think, like Andy was saying, you can't really unify these. So we'll pull and sort of have a secondary governance process where you're constantly pulling data out of these different disparate systems and trying to do a reconciliation of those. The approach that we're taking, which is a little more probably off in the future, but I think is something we really need, is to impose more control at the, and this gets into the cultural change issue, more control at the tool level where people are working on the data to ensure that every action gets recorded by putting these in what we call controlled data spaces. And that, again, that's sort of a change in culture of how things are done. People are used to being able, once they have access, there's lots of you know, work being done on controlling access and security, but often we stop there and say, okay, now you've got control of the, or you access the data, do whatever you want to with it. So we have a lot of end user or shadow IT. So those are the two main approaches. We've finally been working on the latter, where we're trying to build positive data control spaces.
One other, that's great. You know, I think John's dead on. And, you know, one of the things that I love about what he just said is these controlled data spaces have gotten a lot worse in the last 10 years with the proliferation of data scientists. Essentially, every data scientist using whatever sort of last mile data prep tool to iterate on the data in their own way. And there's some of that that's healthy, that idiosyncrasy, but there's a lot of it that's unhealthy and creates a lack of consistency that's almost uncontrollable. And so I think there's a swinging of the pendulum back from data science to data engineering to kind of get control of some of the core data and a bit more governance. The other thing about cataloging for me is I really like with our customers, some of them, you know, really like to separate out crawling and registry of the sources themselves from the curation of all the data in those sources into a curated version catalog of the data. And those two functions are very different. And we like to compare it to the systems that run at Google. Google has lots of systems that crawl and harvest data from the web. And those systems are relatively independent from the systems that resolve and deliver, you know, organized results to people when they search Google. And so we think there's a healthy separation of crawling and registry from serving curated data that you publish to consumers.
I guess just to add what Andy was saying, you know, what we've done is to that exact point is, you know, people have developed, say, their business data glossary of terms, definitions, and various things like that, and then they have their automated ingestion techniques to bring that metadata in to a repository. The tough part now, and the heavy manual part, is how do I now match up my business glossary with that technical metadata? And so we can again use, you know, similar you know, machine learning techniques to try to automate at least the first pass at that, and then have people and crowdsource the correction of anything that the algorithm didn't quite get right. And that greatly speeds up that process as well.
Okay, 10 minutes. Wayne, next question.
Yeah, so Victor, while we're on you here, there was a question for you. Comment was, CogniSteward offerings are very impressive. Did your data science team develop the algorithms, and what is the backend architecture providing the technology process? Is it AWS, Azure, Google, etc.?
Yeah, so great question. Yeah, so we have developed all the algorithms ourselves, or are using some open source algorithms as part of that. It's really just using you know, Python type scripts and other code to run that, and it could be run on premise or on the cloud. So we can use it on both. Some of the other things like the text extraction and the image extraction, we use things like the Google API to do some of those techniques, but we've Dockerized it so you can, you know, run it on any of the cloud platforms as well as on premise, because a lot of times clients want to integrate this component right in their existing enterprise data management platform or processes. And so we have it set up that way. It's all, called through APIs and various things like that. And there's a UI GUI as part of it too, so you can work right within the tool.
Thank you. Andy, a couple questions for you. One was, how does Tamer integrate with external data such as D&B? And what's the ballpark accuracy in a percentage format that some of these tools like Tamer offer in automating metadata?
Great questions. So I'll take the second one first. So, I mean, I think the key, whenever using a probabilistic approach to this kind of a thing, precision and recall are kind of the key things to measure. And we spent a lot of time, sort of making the precision and recall, as well as all the stats about how the model is working, transparent to the users that are using the tools. Because one of the challenges you have a lot of times when you use a model to do something like this rather than rules is explainability, which is always hard. And we find that the more people know about what the model is doing and how it's performing, and maybe even more importantly, watching the model's performance in terms of precision and recall improve over time is a tremendous confidence building method. And many of our customers that start with a combination of mix of rules and model, oftentimes after they see the model improving and surpassing the precision and recall numbers that they considered equivalent to the rules, they sort of put the rules to the side and rely on the model a bit more. With regards to the external data sources, we do a lot of enrichment for our customers using external data sets like D&B. We think it's a core sort of function, and we believe, especially with when you look at key entities like companies and sort of organizational data, organizational hierarchy data, there's tremendous benefit for large companies, especially, to use external data as actually sort of their primary source. One of the ways to think of this in our minds is that if you think about the data that's in D&B, the phone number for any small or medium-sized business, the likelihood that the phone number for that company in D&B is more accurate or more likely to be accurate than the phone number that's on that company's website is very low. And so, we think there's tremendous value to be gained by using just publicly available and very inexpensive, if not free, data in order to enhance and enrich internal data around suppliers and customers, as an example. Yeah. Hope that helps.
Yeah.
Two more questions, Wayne?
Yeah, absolutely. There's been a very technical discussion about data quality. I'm wondering, what are the people and process challenges that you see most and solutions to addressing them?
Well, yeah, so, the best place to fix data quality is at the source, right? So, I've always been advocating for, a culture change right at the point of data entry, where people get measured and should have part of their performance measured on the quality of the data that they're actually entering into the system, right? And then that way you can then follow it all the way, it solves it kind of right at the source instead of trying to patch it up later. And a lot of times you run into that because, there's mandatory fields that the business process hasn't been designed to collect at the point where they're trying to create a customer entry or create whatever it is they're trying to fill in. And so they just put in just dummy entries to get past that mandatory field. So you have to make sure that, the business processes are designed so that the data needed is collected at the right point to remove any of the friction of how that data then gets entered into the system and then flows downstream from there. So that's one of the main things, I've been advocating for.
Yeah,
I agree. I think I'm sorry, go ahead.
Oh, just to pile on what Victor was saying,
Yeah.
We've for a number of our customers have implemented what they think of or call auto suggest and autofill in their mainstream operational systems. And the data to support the auto suggest and autofill in their apps comes from their master data. It's an interesting thing that, that this is a capability that exists on the modern internet that everybody's used to using in modern consumer internet apps, but inside of large enterprises, almost is non-existent. And so having these auto suggest and autofill functions in the mainstream of operational apps, I think is a key way to improve data quality at the point of data creation.
Yeah, I agree that what I find anyway is that there's wonderful things out there. They just don't use them. And so people universally extol data quality. And there's some wonderful data quality management methodologies that have been developed all the way back from Plan, Do, Check, Act up to the new ISO 8061 standards for data quality management. But people don't do that. They don't implement those. You're talking earlier about the precision recall F measure. Hardly any of the people that I work with in their master data management have ever measured that. So they don't know what it is. So all they do is just compare, what you do to what they do. And, you don't really have hard numbers for those kinds of things. So yeah, the biggest issue is that people talk about, they want good data governance, they want good data quality, but they don't use the methodologies that are already there and developed, and the kind of tools that you're talking about, Andy, that are available. So I think that's where the big gap is between, talk and practice.
Yeah, and that brings to my final conclusion. I like all the discussions, and I actually learned a lot today, but I call for this session for a selfish purpose, which is I believe that we ought to have a way of defining this as an academic and industry standard. So let me recall, in 1986, there's an Italian professor called Battini and several others. They published in computing surveys in ACM called something like a methodology for schema integration when you have multiple databases, or view integration if you only have one database. I was a PhD student at that time. I had to study that paper and memorize it, and it was very good methodology, even though at that time there are thousands of approaches. So what I'm hoping for is somewhere along the line, someone, doesn't have to be me, we can come up with a methodology or a framework or a recipe for data washing machines that the industry people can make millions of dollars and academics can produce lots of research papers. And it's 3 o'clock now. So thanks everybody. And thanks for attendees. I want to tell you that we started with 50 people and we ended up with 85 people attending us. I say that's pretty good. Have
Okay,
fun.
Thanks.
Very good.
Thanks,
Thank you,
Richard.
everyone.
Thanks, everybody.
everyone.
Thank you.
Thank you.
Thanks, everybody.